Right, so this problem says a 200-gallon tank initially has 100 gallons of a salt solution that contains 5 pounds of salt. A salt solution is pumped into the tank at a rate of 4 gallons per minute with a concentration of 1 pound of salt per gallon. The well-mixed solution is pumped out of the tank at a rate of 2 gallons per minute. So how much salt will be in the tank after 30 minutes and round to 1 decimal place? So we use variable Q or A. Some books use A for the amount of salt in the tank after time T. And this equation is going to say the rate of change of that salt is going to be equal to the rate of change of the salt going in minus the rate of change of the salt going out. And the rate going in is going to be the solution rate going in times the concentration of that, the concentration of salt in that solution going in minus the rate of the solution going out times the concentration of salt going out. If you multiply the rate times the concentration of salt, you get the amount of salt going in and out, okay? And all that's given here. So here, the rate going in is 4 gallons per minute, right? So 4 gallons per minute going in. It says with a concentration of 1 pound of salt per gallon. You can see if you multiply these two together, the gallons are going to cancel out and you're going to get pounds per minute. So you're going to get a rate of salt going in. And then the rate going out is 2 gallons per minute. And the concentration going out, it doesn't tell us. So, the tank is being mixed and what's coming out is everything mixed together. So the concentration of salt will be the amount of salt that's in the tank divided by the volume of the salt, right? So this concentration was amount of salt per gallon. The gallon is a measurement of the volume. So the concentration going out is going to be how much salt's in the tank, and that's just going to be the variable Q at time T, and then divided by the volume. And it's actually going to be a function of time too, because it's going to change. So we need to figure out the volume of the solution in the tank. So it tells us that the tank is 200 gallons, but it's only got 100 gallons of the solution to start with. Okay, but if the solution is going in at 4 gallons per minute and it's only going out at 2 gallons per minute, that means the volume is going to be increasing by a constant of 2 gallons per minute, right? So you could set up a differential equation for that. You could say the rate of change of the volume is 2 gallons per minute. Antiderivative of both sides, you get 2t plus c. C is the initial value of the volume. So the volume at time 0, if I plug in 0 for t, the volume is 100, right? So you get the volume is 2t plus 100. Now you could have figured this out just by using just regular algebra, but we're in differential equations, so you could have made it a differential equations problem. All right, so now I have all the pieces I need to write my differential equation. So Q prime is 4 times 1 minus 2 times Q over 2t plus 100. So just some simplification. This is 4, and then 2 over 2t plus 100. That's going to be, the 2's will cancel out, so you get t plus 50. You could factor out a 2 here and then cancel it out with that 2. Right, so I'm just going to rewrite this a little bit. I'm going to move the Q to the left, and I'm going to put this coefficient in front of Q. That's equal to 4. So this is another linear equation. So we could use integrating factors. So, this is our P. If I'm the antiderivative of 1 over T plus 50, you could do a U substitution, and you get du is just T dt, or sorry, 1 dt. It's just dt. So this is integral of 1 over u, which is natural log of absolute value of u plus c, and u is T plus 50. Now for the integrating factor, I don't need the plus c. I just need one function that makes it work. And because time is going to be 0 and up, I can drop the absolute values here. So my integrating factor will become u is e to the natural log of T plus 50. And those cancel out, so you just get T plus 50. So I'm going to multiply both sides by T plus 50. When I multiply it times the second term, they cancel out. You just get Q, and then 4 times T plus 50 on the right side. Just verify that you have the product rule. The derivative of T plus 50 is just 1. So that's my coefficient of Q, so it does work. So we're going to reverse the product rule. So I get T plus 50 times Q, and then all that prime. I'm just going to go ahead and say this is 4T plus 200. Antiderivative of both sides. So antiderivative of 4T would be 2T squared, and then plus 200T, and I do need the plus C here, because I do want all the solutions to start with. And then to solve for Q, all you got to do is divide by T plus 50. All right, so we need to solve for C now. So we need an initial value. The problem says that the tank initially contains 5 pounds of salt. So that's our initial value for the amount of salt in the tank. So Q of 0 equals 5. So I'm going to plug in 5 for Q. Then I'm going to plug in 0 for all the T's. So that will just leave me with C in the numerator and 50 in the denominator. Multiply by 50 on both sides, and I get C is 250. So my function is now Q equals 2T squared plus 200T plus 250 over T plus 50. Right, so now we're going to answer the question. The question says how much salt will be in the tank after 30 minutes. So all we've got to do is plug in 30 for T and just find out how much salt's in the tank. I'm going to use a calculator here. So 2 times 30 squared plus 200 times 30 plus 250. I'll just do the numerator first, and then I'm going to divide by 80. So 100.625 pounds. Let's see, the problem says to round to 1 decimal place. So I'm going to say this is rounded to 100.6 pounds.